What are the chances that the Earth, the Sun, and even distant stars would all erupt within the same 3-day stretch? In just 72 hours, 2 stars exploded so brightly they could be seen without a telescope. At the very same time, twin magnitude 6 earthquakes rattled Venezuela, and a massive solar storm slammed into a rare interstellar comet speeding through our solar system. Scientists are calling it the 72-hour stack, a once-in-a-generation pileup of cosmic and seismic extremes. The odds of these events overlapping are less than 1 in 1,000, maybe even rarer. But was it all just a wild coincidence, or a clue that we're missing something hidden in the patterns of nature itself? Let's rewind to the very first sign that something extraordinary was about to unfold. Just after midnight on September 23rd, a faint point of light in the southern sky suddenly flared to life. One moment it was invisible to the naked eye, the next it burned bright enough for anyone under a dark sky to see. Astronomers would later name it V1935 Centauri, but for a few breathless hours it was simply that star that wasn't there yesterday. The first person to spot it wasn't a veteran scientist at a giant observatory. It was Gabriela Moya, an amateur astronomer in Valparaiso, Chile. She'd been running remote telescope scans all night, battling clouds and power flickers, when a single frame showed something off. A new pinprick of light where the charts predicted darkness. Unsure if it was a glitch, she triple-checked, then sent an alert to the Central Bureau for Astronomical Telegrams at 2:12 a.m. UTC. Within minutes, automated survey telescopes in Chile and South Africa confirmed the outburst. What made this sudden glow so remarkable was what caused it. V1935 Centauri is a white dwarf, the burnt-out core of a dead star locked in a tight orbit with a living companion. For years, it had been silently stealing hydrogen gas from its partner, letting the fuel pile up until pressure and heat reached a breaking point. When that threshold snapped, fusion ignited in a runaway flash, hurling the outer layers into space at thousands of kilometers per second, and boosting the star's brightness more than 100,000-fold overnight. For backyard skywatchers, it was a rare treat. A new star, suddenly visible to the naked eye. For scientists, it was the start of an extraordinary chain of events that would unfold over the next 3 days. And while Moya caught her nova just before dawn in Chile, no one could have guessed that the Earth itself was about to join the drama. Just as skywatchers were still buzzing over the nova, the ground in northern Venezuela made its own violent announcement. On September 24th, 6:21 p.m. local time, dinner tables rattled and ceiling fans swung as a magnitude 6.2 earthquake ripped through the Mon Grande region. It struck only 7.8 kilometers below the surface, shallow enough for the shaking to roar straight into streets and homes. Inside the local hospital, lights flickered, glass cracked, and staff rushed patients outside onto the parking lot. One of them, Maricela Rivas, a senior nurse who had just clocked out, grabbed the intercom mic and calmly started directing triage. Red tarps for severe trauma, blue for children. Keep everyone clear of the west wall. Neighbors brought flashlights and plastic water jugs, while volunteers turned pickup trucks into makeshift ambulances. For a brief hour, the tremors quieted and people dared to hope the worst was over. But at 3:51 UTC, just before midnight local time, the Earth moved again. This one registered magnitude 6.3, slightly deeper but centered beneath nearly the same patch of ground. Windows shattered, power cut out, and the same hospital staff had to rush patients back into the open night as aftershocks rippled through the valley. Seismologists later explained it as a classic stress transfer sequence. One fault segment slipped first, loading another until it gave way. But for the residents of Mon Grande, it felt as if the planet itself had joined the week's chaos. Within the first hour, an aftershock at 5.8 forced yet another round of evacuations, with Rivas and her team working by flashlight to keep IV lines steady and children calm. While the region began counting the damage, the clock on that extraordinary 72-hour window kept ticking, and the sky was about to flare again. Barely a day after the second Venezuelan quake rattled nerves, the heavens delivered another shock. On September 25th, 4:05 a.m. UTC, telescopes from Hawaii to Spain lit up with alerts. A new star had suddenly burst into view in the constellation Sagittarius. Its name, V7994 Sagittarii, would come later. At first, all anyone knew was that a brand new point of light had appeared where the sky had been empty the night before. This eruption climbed to magnitude 6.2, bright enough to be glimpsed from a dark field without any telescope, an astronomer's version of lightning striking twice. 2 naked-eye novas in less than 48 hours is almost unheard of. In an average year, we're lucky to see even one. What made this second blast so gripping was how fast it unfolded. High-energy satellites like Fermi and Swift registered an immediate spike in gamma rays and hard X-rays, a telltale signature that shockwaves were tearing through the nova's expanding shell. For a few tense hours, NASA scientists even debated whether the readings were real or just a false trigger, before the optical data confirmed the burst. Astronomy chat groups filled with stunned posts from both professionals and hobbyists. Some were still awake tracking the Venezuelan aftershocks when they noticed the brightening star. Others thought at first it was a camera glitch, until dozens of observers across 3 continents reported the same coordinates. 2 novas in 2 days. A runaway fusion blast lighting up Centauri on the 23rd, and now Sagittarius following suit on the 25th. By this point, even seasoned researchers admitted that the week's events were starting to feel less like coincidence and more like a cosmic pileup. And while the sky was flaring with stellar fireworks, the sun itself was already loading the next surprise. While the novas lit up the night and the quakes unsettled the ground, the sun had its own drama brewing. At the height of solar cycle 25, sunspots were at their most restless in over a decade. On September 24th, just hours before the second Venezuelan quake, the sun unleashed a coronal mass ejection, a colossal bubble of plasma and magnetic fields hurled into space at more than 1,000,000 miles per hour. Normally, that's just another solar storm, the kind that lights up auroras near Earth's poles, but this one was aimed almost perfectly along the orbital path of something extraordinary. 3I Atlas, only the 3rd confirmed interstellar comet ever seen passing through our solar system. Unlike comets born from our own Oort cloud, 3I Atlas is a visitor from another star system. Its orbit slices backward through the plane of the planets at more than 60 kilometers per second, dragging dust and frozen gases that predate our sun itself. In late September, it was skimming just 0.19 astronomical units from Mars, close enough that orbiters around the red planet were already watching it. As the plasma waves sped outward from the sun, astronomers tracked its approach toward the comet's projected path, racing to predict the moment of impact. Space weather monitors showed magnetic readings spiking as the charged clouds swept past spacecraft in the inner system. For scientists, it was a once-in-a-generation natural experiment, a solar storm slamming directly into a comet from another star. For the public, it was a cosmic spectacle hidden just out of sight. No glowing tail in our skies, no flash of light, but behind the scenes, the data told a dramatic story. The collision promised fresh insight into how alien ices and dust react under the blast furnace of a raging sun. This solar strike marked the 4th piece of the incredible 72-hour puzzle. The novas, the quakes, and now a high-speed interstellar visitor caught in the sun's crossfire. But what made headlines wasn't just each individual event. It was the way they all unfolded together, as if the universe had decided to stack the deck. By the end of that 72-hour window, even seasoned scientists were shaking their heads. It wasn't just that each event was unusual, it was how they all landed on top of each other like dominoes. Start with the novas. In a typical year, we might be lucky to witness one naked-eye nova and sometimes none at all. In late September, we got 2. Both bright enough to see without a telescope, and they popped up barely 48 hours apart. Astronomers estimate the odds of that happening at less than 0.002%. Then the quakes. The Venezuelan region usually gets a magnitude 6 quake once every 2 or 3 years. But two major quakes plus a strong aftershock struck the same fault zone within 6 hours. That sequence alone is on the order of 1 chance in 10,000. And the solar strike? A coronal mass ejection slamming directly into a rare interstellar comet isn't even something most models bother to calculate. The probability sinks so low that statisticians joke the calculator just throws up its hands.
Add them together, and the odds of all 4 events overlapping in a single 3-day window drop below 1 in 1,000, maybe far lower, depending on how you run the math. There's actually a name for this kind of statistical curveball: Poisson clustering. It describes the way pure randomness sometimes piles rare things together in short bursts, the way coin flips occasionally land heads 5 times in a row. The math says it can happen, but when it does, it feels like the rules have been bent. That's why scientists dubbed the whole sequence the 72-hour stack, not because they think it was supernatural, but because the timing was so extreme it demanded its own nickname. The numbers suggest coincidence, yet the pattern is so striking it leaves a nagging question. If randomness can deal a hand this wild, what might the next one look like? And as astronomers look ahead, the calendar itself seems to be daring them to keep watching. The September stack might be over, but the sky isn't done putting on a show. In fact, October is shaping up to be one of the most event-packed months for skywatchers in years. First on the list is Comet Swan, officially C/2025 R2 Swan. On October 20th and 21st, it will glide past Earth at just 0.26 astronomical units, about 39 million kilometers away. That's close enough, under the right dark sky conditions, to reveal a delicate green-white tail through a pair of ordinary 7x50 or 10x50 binoculars. The timing couldn't be better. A new moon and the Orionids meteor shower will make the skies darker and busier than usual. For the best view, head out after midnight, well away from city lights, and give your eyes 30 minutes to adapt to the dark. A week later comes the main act, the Mars flyby of 3I by Atlas. On October 3rd, the comet slides within 0.19 astronomical units of Mars, giving orbiters like TGO and MAVEN a front-row seat. While the flyby won't be visible to the naked eye from Earth, it promises a surge of fresh data as instruments track how the comet's strange alien materials react to the solar wind. The big milestone arrives at the end of the month. On October 29th, 3I by Atlas reaches perihelion, its closest point to the Sun at about 1.36 astronomical units. Most of us won't be able to see it without specialized equipment, but researchers hope that its brush with intense sunlight could trigger new jets, brighten its tail, and reveal more about what this interstellar traveler is made of. For those planning to watch, there are 2 golden rules. Use ISO-certified solar filters for any attempt to glimpse it near dawn or twilight, and never point binoculars or telescopes near the sun without proper front lens protection. A few seconds of unfiltered sunlight can cause permanent damage. And that's not all. After its solar pass-by, December 19th brings the comet's closest approach to Earth, when amateur astronomers will have their best chance to capture long-exposure images of its evolving tail. Citizen science networks like the AAVSO, the International Comet Quarterly, and the Comet Observation Database are already calling for public observations, brightness estimates, tail sketches, even smartphone-assisted time lapses. A well-timed photo or careful log from a backyard observer could help researchers understand how the comet changed after the solar storm in September. In short, the next few months aren't just a follow-up. They're an open invitation for anyone with a clear night sky to witness and even contribute to real science. 72 hours. That's all it took for 2 distant stars to erupt, the ground in Venezuela to split twice, and a solar storm to slam into a comet from another star system. On paper, it looks like random chance, the kind of improbable overlap statisticians file under Poisson clustering. But standing under the night sky, watching one headline after another break in real time, it didn't feel random at all. Moments like this remind us that nature's biggest surprises often play out right in plain sight, in the light of a nova, in a ripple under our feet, in a solar storm tearing across the void. Whether it was pure coincidence or a glimpse of deeper patterns we don't yet understand, the 72-hour stack proved how quickly the universe can rewrite the ordinary. October's sky will soon reveal whether that week was just an anomaly or a prelude. With Comet Swan, the Mars flyby of 3I by Atlas, and the comet's December return still ahead, there's every reason to keep looking up, and maybe even take part by sharing your own sightings. What do you think? Was this all just luck of the draw, or does the universe have more surprises lined up than we realize? Drop your thoughts below and tell us which moment from the 72-hour stack shocked you the most. If you want to follow the story of these upcoming events, stay tuned. The sky's next chapters are just beginning.